Hey everybody, we're going to do systems of equations today, and we're going to do different methods. We're going to start off with the substitution method, and I'll outline the steps. We have two equations. Solve an equation, either one, doesn't matter. Solve an equation for one of the variables. And what that means is we take that equation and that we get one variable on the left side by itself. After we do that, we substitute the right side of the equation in step one into the other equation. We solve for the remaining variable. And once we solve for the remaining variable, we plug this value, the value of this variable, into the equation of step one and solve for the other variable. Sound complicated? You bet. But it's only complicated when we don't have actual equations to work with. So let's get an example to work with and simplify everything. Here's a good example to start off with. Here's our system of equations. First equation, y equals 2x minus 1. Second equation, y equals 3x minus 4. And our first step is solve an equation, either one of these, solve an equation for one of the variables. In other words, get one variable on the left side by itself. Well, you know what? Both of these equations are already in that form. Both of these equations have one variable, y, on the left side by itself. So step one is pretty much done for us. And what I'm going to do is I'm just going to pick the first equation. Y equals 2x minus 1. See that? Y is on the left side by itself. Step one is done. Step two, substitute the right-hand side of the equation in step one. That's this thing. The right-hand side of the equation in step one into the other equation. Well, here's the other equation. Y equals 3x minus 4. This is the other equation. And we're going to take the right-hand side of the equation in step one and plug it into the other equation. So 2x minus 1, this is what y equals. We're going to substitute this into that equation. Instead of writing y here, we're going to take what y is equal to, 2x minus 1. And with this equation, we go to step 3. Solve for the remaining variable. And see that? There's only one variable here, x. So in step 3, we solve for x, the remaining variable. And the first thing that I'm going to do is move this negative 1 to the right. I'm going to add 1 to both sides. So that'll give me 2x equals 3x, and I'm adding 1 to both sides, so that will give me negative 3. Next, I'm going to move this 3x to the left. I'm going to subtract 3x from both sides. 2x minus 3x is negative x. Have I solved for x yet? No, not quite. I have negative x here. I'm looking for positive x. So I'll just multiply both sides by negative 1, and that will make the left-hand side equal to x. So I solved for the remaining variable x. Do I know what y is yet? No. But that's what step 4 is all about. Plug the value of this variable, x equal 3, into the equation of step 1 and solve for the other variable. So take the value of the variable in step 3 and plug the value of the variable in step 3 into the equation of step 1. Okay, here's my equation in step 1. Y equals 2x minus 1. And I'm going to take this value of x and plug it into that equation. Now all I have to do is simplify, right? Let's see, can we see that? I guess we can. I'll just simplify. This gives us y equals 6 minus 1 is 5. We just got the value of y. So our solution, or maybe I should say the solution of the system, is xy, x was 3, y was 5, am I done? I have a solution. Yeah, kind of I'm done. But you know what? I should take my answer and check it and make sure that it works. So here's what I'm going to do. I'm going to take this value of x and this value of y and plug it into each of these equations and make sure they work. The first equation, y equals 2x minus 1. Y is 5. X is 3. Does 5 equal 6 minus 1? Well, I'll tell you what. 5 equal 5? Yeah. So it works for the first equation, but let's make sure it works for the other one too. We'll take the second equation, y equals 3x minus 4. And we'll plug 5 in for y, and 3 in for x, and then simplify. 5 equals 9 minus 4 is 5. Yep, okay. We checked our answer, we plugged it back in, it worked. So now we can say that that's the solution. Now we have a solution. Let's do a couple more of these, okay? Okay, here's another good example that we're going to do by the substitution method. First equation, 3x plus 4y equals -2. Second equation, 5x plus y equals 11. And step 1 says solve an equation, and it doesn't matter which one. Either equation will do. Solve an equation for one of the variables. In other words, take one of these two equations and get one of the variables on the left side by itself. And I'm looking at this and I see y right here. Just y by itself. It's not something times y, it's just y by itself. And I'm thinking, you know what? I can just move this -5x to the right side and y will be on the left side by itself. So I'll take this equation, -5x plus y equals 11. And I want to get that variable all by itself. So I'm going to take -5x and move it to the right. And how am I going to do that? I'm going to add 5x to both sides. I add 5x to this side, and that gives me 0x plus y. I add 5x to this side, that gives me 5x plus 11. And bingo, I got y on the left-hand side by itself. Step 2 says, substitute the right-hand side of the equation in step 1. Here's the right-hand side of the equation in step 1 into the other equation. Okay, well this is the equation we used in step 1. So this must be the other equation, so to speak. So I'll take 3x plus 4y equals -2. And I'm going to take the right-hand side of this equation and substitute it for y in the equation down here. So that will give me 3x plus 4 times y, but y is the same thing as 5x plus 11. So you see that? I took y, which is 5x plus 11, and substituted it into this equation for y. And that brings us to step 3. Take this equation and solve for the remaining variable. The remaining variable, yeah. Look at this equation. X is the variable that remains. So we're going to solve for x in step 3. But it looks like we're going to have to simplify first. I'm going to take this 4 and distribute it inside the parentheses. So that'll give me 3x plus 4 times 5x is 20x. 4 times 11 is 44 equals -2. Now let me just make sure that I did that right before I go on. 4 times 5x is 20x. Yep, that's good. 4 times 11 is 44. Okay, that's good too. Now, let's see. 3x plus 20x, what's that? 23x I'm going to move this to the other side. So that means I'm going to subtract 44 from both sides. If I subtract 44 from the left, that will leave me with nothing. If I subtract 44 from the right, that's negative 2 minus 44 is negative 46. Okay. (23x) equals negative 46. To find x, the remaining variable, I just have to divide both sides by 23. I divide this side by 23 and I get x. And if I divide 46 by 23, I get 2. So if I divide negative 46 by 23, I get negative 2. So I've got half of my solution already. I have the x value. Now I just have to find out what the y value should be, and that takes us to step 4. Plug the value of this variable, x equal negative 2, into the equation of step 1. That's this guy. And solve for the other variable. So take the value of x equal negative 2, take x equal negative 2, and plug it into this equation. The equation of step 1, that's negative 5x plus y equals 11. And I'm going to take negative 2 and plug that in for x. So that'll give me negative 5 times negative 2 plus y equals 11. Negative 5 times negative 2, that's 10. 10 plus y equals 11. And I'm solving for y, so I'm going to move this 10 to the right. I'm going to subtract 10 from both sides. 10 minus 10 is 0, and that leaves me with y on the left. 11 minus 10 is 1. So there's my y value. And tentatively, my solution is x equal negative 2. Whoops. X equal negative 2. Y equal 1. That's my tentative solution. But before I declare that I have a solution, I'm going to check. Here's what I think my solution is. I'm going to make sure that this solution satisfies both of these equations. And if it does, then I'll concede that I have a solution. So I'll plug x equal negative 2, y equal 1 into the first equation. 3x plus 4y equals negative 2. I'll take negative 2 for x. I'll take 1 for y. And that leaves me with negative 6 plus 4 equals 2, or, I'm sorry, negative 2. Negative 6 plus 4 is negative 2 equals negative 2. Okay. It It satisfies the first equation. Let's make sure it satisfies the second as well. Negative 5x plus y equals 11. I'll take negative 2 for x, 1 for y, and that gives me negative 5 times negative 2 is plus 10, plus 1 equals 11. So that gives me 11 equals 11. Check, 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 check. Okay. Our solution satisfies both equations. So now I will declare positively I found the solution to this system of equations. Next example. The equations 2x plus 3y equal 12, 2x plus 6y equal 18. In our first step, solve one of these equations, either one, it doesn't matter, for one of the variables. In other words, get one of these variables on the left-hand side by itself. And I'm going to take the second one because here's what I'm thinking. I'll move the 6y to the other side, and then I'll divide both sides by 2, and I'll get whole numbers. I don't see that happening here. In the second equation, this one, I'm going to solve for x. The first thing I'll do is I'll move 6y to the other side. I'll subtract 6y from both sides. Well, I still don't have x by itself. I have 2x. So what I'm going to do is I'm going to continue with this equation. What do I have to do to make this just plain old x? Divide both sides by 2, right? 2x divided by 2 is just x. Negative 6y divided by 2 is negative 3y. 18 divided by 2 is 9. Okay. Now I got that variable on the left by itself. My next step, take the right-hand side of this equation and substitute it into the equation of step 1. Here's the equation that I used in step 1. You know what? You know what? Maybe I'm a dummy. Solving for x wasn't wrong, but I didn't need to do that. Here's the equation of step 1. Now I can take this, negative 3y plus 9, and substitute that in for x. And that'll be fine, it will work. But you know what? I could take this equation and take negative 6y plus 18, that's equal to 2x. 2x equals negative 6y plus 18. So I could take negative 6y plus 18 and just substitute that in for 2x. And that would be simpler, wouldn't it? So I caught myself not looking far enough ahead. This is fine, but it turns out I don't need to do this. What I can do is take the right-hand side of this equation, which is equal to 2x, and substitute that in for 2x. 2x is equal to negative 6y plus 18. Plus 6y equals 18. Well, this is going to be interesting. Oh, you know what? I've done something wrong. I sure have. Let me back up. Do you know what I did wrong? Step 2. Yep, that was stupid, stupid, stupid. Substitute the right-hand side of the equation in step 1 into the other equation, this guy. Substitute it into the equation that we didn't use in step 1. So that's 2x plus 3y equals 12. And I already know what 2x equals. It's negative 6y plus 18. So I'm going to take this and substitute it in for 2x. And that will give me negative 6y plus 18 plus 3y equals 12. Oh, that looks so much better. Solve for the remaining variable. This is the variable that remains right here. Solve for y. This is the variable that remains. And let's see. I can take negative 6y and 3y. What is negative 6y plus 3y? Isn't that negative 3y? Negative 6y plus 3y is negative 3y plus 18 equals 12. And then I can subtract 18 from both sides. If I subtract 18 from the left, I just get 0. If I subtract 18 from the right, I get negative 6. Okay, we're getting there. We're solving for y. I'll divide both sides by negative 3. That will make this, let's see, negative 3 divided by negative 3 is just 1. So that'll be y. Negative 6 divided by negative 3 is 2. Okay. So we have the y value. And step 4 says plug the value of this variable into the equation of step 1, 2x plus 6y equals 18. So we'll take the equation of step 1, 2x plus 6y equals 18. And I'm going to take negative 6 and plug that in. Oh, not either. I'm going to take y equal 2 and plug that in for y here. And that will give me 2x plus 6 times negative 2 equals 18. Six times negative 2 is negative 12, so we have 2x minus 12 equals 18. And I'm going to move this negative 12 over to the other side. I'm going to add 12 to both sides. 12 plus negative 12 is 0. 12 plus 18 is 30. And I do not like this at all. Hold on just a minute. Okay. I'm making a mess out of this, and I apologize. In step 3, I had y equal 2. And in step 4, I plugged the value of this variable, y equal 2, into the equation of step 1, 2x plus 6y equal 18. Okay. Take this value, y equal 2, and plug it into the equation of step 1. Does it look like I plugged in 2 for y? No, it doesn't. For some reason or other, I plugged in negative 2. Now, if I plug in 2, I think that will make everything so much better. That'll give me 2x plus 12 equal 18. And I'll move this 12 to the other side. 12 minus 12 is 0. 18 minus 12 is 6. This is looking much better. The only thing I need to do now to get x is just divide both sides by 2. 2x divided by 2 is x. 6 divided by 2 is 3. So my tentative solution is x equal 3, y equal 2. But is it really the solution? That we'll have to check. Plug these values into the first equation. 2x plus 3y equal 12. X is 3. Y is 2. And that gives us 6 plus 6 equals 12, or 12 equals 12. Our tentative solution, or our prospective solution, works for the first equation. Let's make sure it works for the second too. 2x plus 6y equal 18. X equals 3. y equals 2. So that gives us 6 plus 12 equals 18. Check. Okay. Our prospective solution satisfies both of the original equations. We can stop. Let's look at one other thing that can happen when we solve a system of equations. Let's look at this example. We need to see something like this. X plus 2y equals 5. 2x plus 4y equals 12. Our first step, solve one of these equations, either one, it doesn't matter, for one of the variables. So in other words, get one variable on the left side by itself. This is probably going to be the easiest. If we move 2y to the other side, we'll have x by itself on the left. So we'll take this equation and move the 2y to the other side. Subtract 2y from both sides. Bravo. Now, we take the right-hand side of this equation and substitute it into the other equation. Here's the other equation. 2x plus 4y equals 12. Substitute this in for x in the other equation. So we'll take 2x, which is 2 times negative 2y plus 5. So here's 2x plus 4y equals 12. And we're going to have to simplify that. Two times negative 2y is negative 4y. 2 times 5 is 10. Plus 4y equals 12. Oh, look at that. We have negative 4y plus 4y. That's 0, right? So all we have left on the left-hand side is 10. And on the right-hand side, we have 12. Well, since when is 10 ever equal to 12? Never. This is impossible. We're looking for a solution to both of these equations. And any pair xy that's a solution to both of these equations will have to make 10 equal to 12. 10 is never equal to 12. And what that means when we get something like this, 10 equal 12, or if we subtracted 10 from both sides and got 0 equal 2, what that means when we get something that's impossible is that there is no solution. And in mathematical lingo, we'd say the equations are inconsistent. Whenever we get something like this, 10 equal 12, or 0 equal 2, or something like that, something that's impossible, what that means is that there's no solution. The equations are inconsistent. New method, same kind of example. Solving a system of two equations. We're going to call this the addition method. And the first step, get our equations in the form x term plus or minus y term equals some constant. Second step, multiply one or maybe both of the equations by the right constants so that when we add the equations together, one of the variables disappears. Step 3, actually add the equations together. Step 4, solve for the variable in step 3. And step 5, plug the value of step 3, the value of the variable in step 3, into either of the equations in step 1 to get the other variable. Well, let's do an actual example so that this will make sense. This looks like a nice example. Let's go for it. First step, get the equations in the form x term minus y term equals constant. Okay, it's already done for us. Step 1 is done. We have x term plus y term equals constant. Okay. Second step, multiply one or both of the equations by constants so that when we add the equations, one of the variables disappears. Okay, how are we going to do this? Well, I think what I'll do is I'll just multiply the first equation by negative 3. If I multiply the first equation by negative 3, that will give me negative 3x plus 3x is 0. The x's will disappear. Okay, so here's x plus 2y equals 15. And I'm going to multiply both of those by negative 3. The other equation I'm going to keep as it is. 3x plus y equals 5. The first equation, if I multiply both sides by negative 3, I get negative 3x. Negative 3 times 2y is negative 6y. And negative 3 times 15 is negative 45. Okay. And this equation, just going to leave it as it is. 3x plus y equals 5. Okay. Step 3, add the equations. Well, I already have them written out so that they can be added. Negative 3x plus 3x is 0. Negative 6y plus y is negative 5y. And negative 45 plus 5 is negative 40. You see that? One of the variables disappeared. That's exactly what we wanted to happen. Step 4, solve for the variable in step 3. In step 3, we have negative 5y equals negative 40. So I'm going to divide both sides by negative 5, right? Negative 5y divided by negative 5 is y. Negative 40 divided by negative 5 is positive 8. So that's part of our solution, y equal 8. And now we'll do step 5. We have y equal 8. We need x. Step 5 says plug this value into either equation of step 1 to solve for the other variable. Well, I have y equal 8 here, and I have y here, so I'll pick this equation. I have 3x plus y equals 5. And I'll plug 8 in for y. So that will give me 3x plus 8 is equal to 5. And then I'll move this 8 to the right side by subtracting 8 from both sides. If I subtract 8 from the left side, I have 3x. If I subtract 8 from the right side, 5 minus 8, negative 3. And to get x, I'll divide both sides by 3. 3x divided by 3 is x. Negative 3 divided by 3 is negative 1. Okay. This is our tentative or our prospective solution. Let's check. X plus 2y equals 15. And we have xy equal negative 1, 8. Negative 1 for x, 8 for y. That's negative 1 plus 16 equals 15, or 15 equals 15. Check. Works for the first equation. Let's put it into the second one and make sure it works. 3x plus y equals 5. And we have xy equal negative 1, 8. Put 1 in for x. Put 8 in for y. So that gives us negative 3 plus 8 equals 5, or 5 equals 5. Bingo, it works. Okay, now I admit that this is our solution. I've checked and I've confirmed that it actually does work in both equations. equation. Let's do one more. This one looks like a nice example. Negative 2y plus 3x equals 9. 9x minus 5y equals 24. The first step, get the equations in the form x term plus or minus y term equals constant. And this equation is not in that form. We need to switch the x and y terms. So we'll put 3x first, minus 2y equals 9. This equation's good as it is. X first, y second equals constant. 9x minus 5y is 24. The next step, multiply one or maybe both of the equations by constants so that when we add them together, one of the variables disappears. And I think I'm going to try to make x disappear. If I multiply the first equation by negative 3, that will make this negative 9x. And when I add it to positive 9x, I'll get 0. The x's will disappear. So I'll take the first equation, 3x, the first equation, 3x minus 2y equals 9, and I'll just multiply both sides by 3. The second equation is fine. I'll just keep it the way that it is. 9x minus 5y equals 24. I have negative 3 times 3x is negative 9x. And negative 3 times negative 2y is positive 6y. Negative 3 times positive 9 is negative 27. Okay, that looks good. The second equation I just keep exactly the way it is. 9x minus, 5y. 9x minus 5y. 9x minus 5y equals 24. Step 3 says, add the equations. Negative 9x plus 9x is 0. Beautiful. We got rid of the x's. 6y minus 5y is just plain old y. And we add the constants. Negative 27 plus 24 is negative 3. Son of a gun. Solve for the variable in step 3. We got it already. Y equals negative 3. Only one step left. Plug this value into either of the equations in step 1 to solve for the other variable. Let's see. Y equals negative 3. Let's put it in here. 3x minus 2y equals 9. Okay. And we're going to take negative 3 and put it in for y here. So that will give us 3x minus 2 times negative 3 equals 9. that gives us 3x, negative 2 times negative 3 is plus 6 equals 9. What should I do now? Subtract 6 from both sides, right? 6 minus 6 is 0. 9 minus 6 is 3. I have 3x equals 3. What do I do? Divide by 3, both sides. 3x divided by 3 is x. 3 divided by 1 is, 3 divided by 3 is 1. So this is the second part of our prospective solution. Are we right? Well, we're going to have to check. Negative 2y plus 3x equals 9, let's see. xy equals 1, negative 3. And we put negative 3 in for y, so that will give us negative 2 times negative 3 plus 3x, x is 1, equals 9. 6 plus 3 equals 9. 9 equals 9. Okay, check. Let's try the other equation. 9x minus 5y is equal to 24. xy is 1, negative 3. Take x equal 1. And y equal negative 3. Let's see, that turns out to be 9 plus 15 equals 24. Bravo, bravo, bravo. Our prospective solution, 1, negative 3, works for both equations. So that is indeed the answer. See, there's one more thing I should show that we haven't seen, and I need to just make you aware that this kind of thing can happen. Here's a good one, and we need to see an exercise like this. Negative 2x minus 3y equals negative 12. 4x plus 6y equals 24. Step 1, get the equations in the form x term plus or minus y term equals a constant. We got it. X term, y term, constant. X term, y term, constant. Next step, multiply one or both equations by constants so that when we add them, one of the variables disappears. Now here's what I'm thinking. If I multiply the top equation by 2, I'll have negative 4x, and when I add that to 4x, the x's will disappear. So let's do that. Let's multiply the top equation by 2. 2 times negative 2x minus 3y, equals negative 12. And the second equation, 4x plus 6y equals 24. Okay, let's multiply that top equation. I forgot my parentheses, forgive me. There we go. We're multiplying this equation by 2. 2 times negative 2x is negative 4x. 2 times negative 3y is negative 6y. 2 times negative 12 is negative 24. And the second equation we'll just copy down as it is. 4x plus 6y equals 24. And then step 3 says add the equations. Well, we know what's going to happen. The x's are going to disappear. Negative 4x plus 4x is 0. And negative 6y plus 6y, ooh, that's 0 too. And then over here, negative 24 plus 24 equals 0. We can't solve for the remaining variable because there is no remaining variable. And this situation is a little bit different than the one that we saw before where we were substituting. The one we saw before, we had 10 equals 12, which boiled down to 0 equals 2. Here we don't have 0 equals 2, we have 0 equals 0, which is always true. What values of x and y will make this true? All values of x and y will make this true. So when we see this, 0 equals 0, or 12 equals 12, or 5 equals 5, what it means is there are infinitely many solutions. Most of the time when we have a system of 2 equations, we have one solution. One value of x and one value of y, one pair, x, y, that makes this system work. Here, when we see something like this, 0 equals 0, that tells us that we have infinitely many solutions.